All right, let's see. Between what two perfect squared numbers is 70 found? 64 and 81. So that means if I take the square root of the smallest one, it's going to be, this one's approximately 8 something. So my whole number is 8. How do I find the decimals? Subtract the middle from the small. That's my numerator. The large from the small. And that's my denominator. All right, let's find the decimal form of that fraction. 6 divided by 17 does not fit. Add a decimal. Add a 0. Fits in there 3 times. 3 times 17 is 51. Subtract, that's 9. Add a 0. Bring that down. 17 fits in there how many times? 5. That's 85. Subtract, that's 5. And I'll stop right there because they only want it to the nearest what? 10, which is the 3. So does the 3 stay a 3? No, it goes up because this one is 5 or greater. So it goes up to a 4. So square root of 70 is approximately 8.4. One more, or we got it? Okay. All right. Our objective for today, I can derive the distance formula and compute the distance between 2 points. I can derive the distance formula and compute the distance between 2 points. I can derive the distance formula and compute the distance between 2 points. All right? And your home plate, you already copied it. That was 10 problems, yes? All right? Once again, if you didn't copy the objective, it's always over there, yeah? All right, so for the home plate, it says use the distance formula to compute the distance between the 2 points, or the points, round to the nearest tenth if needed. Some of them will need to be rounded, okay? So, we started, I remember back then when we were in Algebra 1, I did do an introduction of the distance formula, but it was in a different presentation. Let's see if you remember. Who remembers the Pythagorean Theorem? Yeah, some of us, right? But here it goes again for some of us that forgot. Pythagorean Theorem comes from this mathematician known as Pythagoras. And I think I remember telling you the story about Pythagoras, remember in class? Pythagoras was a mathematician, and back then, mathematicians were the advisors to the kings because they knew how to predict the future. So let's say there was an army of invaders arriving in San Diego, and I was Pythagoras, and let's say this kingdom had a queen instead of a king. Let's say the queen was Chelsea, and Chelsea's Pythagoras, can you figure out when the army is going to arrive in our imperial kingdom? Sure, give me 2 scouts with horses and I'll figure it out. So then I'll send 2 scouts, Colton and Larissa. Get on your horses, go to San Diego, non-stop. I don't want you to stop at Pine Valley for those pies or anything like that. And I want you to get there, and then I want you to hide and count how many steps the army takes after you count 3 Mississippis. Back then there was a Mississippi. 1 Mississippi, 2 Mississippi, right? So they count, bring that information back, and Pythagoras says to the queen, my queen, the army is going to arrive in 4.5 days. And then that gave the kingdom of imperial time to prep for the invasion. So then all of a sudden, people heard that Pythagoras had figured out that in 4.5 days the army was going to arrive. And guess what? 4.5 days later, who arrived? The invaders. So they're like, Pythagoras is a wizard. yet he was just using the distance formula. Distance equals rate times time. So what the queen plotted to do to get Pythagoras by himself and execute him, because she found him a threat to the kingdom, because he might want to take over the kingdom because he's like a wizard and knows it all. So he started leaving. He left, and he was going from town to town recruiting mathematicians. But they couldn't take notes because of the evidence. So he started recruiting just using mental math. For example, you guys ready? Here it goes. Take the first prime number. Double that. Multiply that number times 3. Divide the new number by 6. Show me with your fingers what you got. Whoever got 2 are part of the Pythagoreans. Let's go. Why? Because they needed to do the math fast, and they needed to give the math. I know some of you are like, I have no idea what they were doing. They needed to give the math to the other people. So they said, what can we do to recognize who's part and who's not? Because I'm going to be going far, and I want to send my people. Well, let's get the medallions going. So they got the medallions, and guess what was in the center of the medallion? A right triangle. Let's go. Be nice. So they were known as the Pythagoreans. Eventually they caught up to Pythagoras. He was executed, but his mathematics continued on. Is that good or not? Yeah? Okay. So he found out that if we have a right triangle like this one, and he started playing with numbers and patterns, and he thought, I'm going to label this one 3 and this one 4. And he said, I'm going to make a shape next to 3 that looks like a square, so this will be 3 squared, which means 4 is what? 4 squared. And he said, let's see if it matches to this side, so this is 5 squared. So he figured that there was a relationship between these two and this. Between what? These two and this. Tell your neighbor the relationship. What is that relationship? Very good. For those of you that don't see it, because some of you looked at me like, I don't know, Mr. Q. Let me show you the relationship. I'm going to take this one. I'm going to bring it here. You guys see it right there? How many other squares are not covered yet? How many squares are in the other square that I didn't use? So what can we conclude? That this plus this gives us. So he figured, what's a way that I can write that so that people can understand it? This is 3 squared plus 4 squared equals 5 squared. And he tried it with different numbers. And he said, but I need to simplify it, as the Jackson 5 said, simplify it as A, B, C, yes? C easy as 1, never mind. A squared plus B squared equals C squared. That's where we get the Pythagorean Theorem. Is it coming back? Yes? All right. Well, let's see if it's true. Copy this one. Example 1Q. Pythagorean Theorem. We have a right triangle with one side 8 centimeters, the other side 15 centimeters, and the longest side, C. We need to figure out what C measures. Now, does everybody see the right angle right here in red? Okay. Remember, the longest side is always across from the right angle. The longest side. The other two sides are known as legs. Hopefully it's coming back, yes? So, we use our Pythagorean theorem. A squared plus B squared equals C squared. So what is our longest side? C is C. There it is, C squared. A and B, doesn't matter which one is which as long as you substitute. So which one do you want to make A? 8 squared plus 15 squared. What is 8 squared? 64 plus 225 equals C squared. That is 289 equals C squared. How do we solve for C? Take the square root. This cancels this. Square root of 289 is 17 equals C. C is 17 centimeters. Yeah, is it coming back? Yeah, right? We got this. Questions, comments, autograph? You good? Yes? All right. So, cautionary note though. Look up, please. We understand that A squared plus B squared equals C squared. You agree with that? Yes? We just used it. And you do agree that 3 squared plus 4 squared equals 5 squared, because we just did one of those. Yes? All right. However, if I wanted to continue just with variables, what would I need to do here to solve for C? Square root. Is that correct? That means I need to do square root to the other side. Hands if you agree up to right there. Okay. So look what I'm going to end up after this here. I'm going to end up with C equals, what would I write next? Very good. Square root of A squared plus B squared. Some of you are like, what were you guys thinking? Were you guys thinking A plus B equals C? Some of you thought that, right? Because it's obvious our noodle's thinking, well, if it cancels this, it cancels that. Let's see if it works with numbers. Is 3 plus 4 equals 5? No, that means A plus B is not equal C. They're like, how come it doesn't work, Mr. Q? Let me give you a clue. Because of that addition sign. There's an operation already involved other than the squaring. That's why you cannot just take the square root. Now, for those of you that still are a little bit iffy about it, let me show you now with a different operation. 2 squared times 3 squared equals 6 squared. So if I was to do, what is 2 squared? 4. What is 3 squared? 9. What is 6 squared? 36. What is 9 times 4? Is 36 equal to 36? Yes. All right. But what if I just wanted to do the square root at the beginning, Mr. Q? All right, let me do that. I end up with 2 times 3 equals 6. What is 2 times 3? It did work here, Mr. Q. Why? Because it's what? Multiplication. Why didn't it work over here? Addition. Everybody with me? Yes? All right. Copy this next one, please. I have a right triangle, 30 feet, 40 feet for the legs, and C for our longest side. Copy that, and go. Check your work. Hands if you got that. And what is the only thing that's missing? People? Feet. Make sure you label it with the units of measure that they give you. Double check your work. All right. Get your graph paper in front of you. Let's do example 2 mega Q, I think it is. One mega Q, I'm sorry. Copy that on the top left. It says compute the distance between the points 2, 8, and 4, 4. 2, 8, and 4, 4. All right, so first we plot our points. 2, 8. 4, 4. Draw the line for the distance that you need to compute. There it is. Nice and straight like mine. All right. Do you see the right triangle? Show your neighbor the right triangle that you see. Oh, sorry. Maybe this is throwing you off. Let me. All right. Do you see the right triangle? Here, let me show you. Who saw that one? Who saw the other one? Yeah. There it is. Either one works because this remains the longest side, yes? So what is A? 2. Very good. What is B? 4 and 4. Well, it doesn't matter which one's A or which one's B, as long as A and B are 2 and 4, or 4 and 2. So A squared plus B squared equals C squared. 2 squared plus 4 squared equals C squared. What is 2 squared? 4. 4 squared, 16. C squared. 4 plus 16 is 20 equals C squared. How do we solve for C? Square root. Square root of 20 equals C. Could we leave it like that? Does everybody see what we need to do? So you know what to do from there? Yeah. Estimate and find decimal to the nearest tenth. Bam. Between what two perfect square numbers is 20 found? 16 and 25. So that means square root of 16 is 4. So the answer is going to be 4 point something, yes? Approximately C. So let's see what that is. So what is 20 minus 16? 4. And what is 25 minus 16? 9. 4 divided by 9 does not fit in there. Add a decimal and a 0. 4. 36. Subtract 4. Add a 0 and it repeats. So does that stay a 4? Does it go up to a 5? Stays a 4. So this is 4.4 units because they don't give us a unit of measure. There it is. Well, we just did in the warm-up, right?
Yeah. Yes, Mr. Q.
All right, how we doing? Good? Piece of cake? Yeah, we got this. All right, show me the famous outcome to you are with finding the distance using the Pythagorean Theorem. 5, 4, 5, 4, 5. Yeah, we got it. Well, good, because we're not going to do that for your homework. We're going to use the distance formula. That was good how I reeled you guys in, right? Really good. Distance formula. Writing your pencils down, look up to the screen. Here we go. Focus, please. Please focus. If I was to say plot 2 points, and the points being 5, 5 and 8, 9. I want to find this distance. Well, we know by the work that we did on the prior one that we see a triangle. Do you guys see the triangle? What would we use? A squared plus B squared equals C squared. Does everybody see? So what does that mean, Mr. Q? That I still need to find this distance? Yes. And do I need to find that distance? Yes, because we need A and B. So, what is this distance, everyone? 3. Let's look at the x values of both points. What is the x value for this point? And the x value for this point? So you know what you need to do with those? Very good. 8 minus 5 gives me 3. What is the y value for this point? And the y value for that point? 9 minus 5, that gives me 'Is everybody okay up to right there? And we would substitute and so on and so forth. But what if I said, let's do it again, but without numbers? 0.1, 0.2, and I want to find the distance. Yes? What does that mean, Mr. Q? Wait a minute, I found the same like earlier, right? What does that mean, Mr. Q? That I need to find this distance? Yes. So that means I need to find that distance. Yes. So let me give you the coordinates for this point. X sub 1, y sub 1. How about this point? X sub 2. How about this? Y sub 2. All right. Tell your neighbor. Oh, this is a little bit off. There it is. Tell your neighbor what I need to do here to find this distance. Let's see. Laisha, what do I write here? Very good. X2 minus X1. Let me go back to the previous one. I did what? 8 minus 5. Yes? X2 minus X1. That means here, what do I write? Monse. Y sub 2 minus y sub 1. Now I have my distance. All right, so now we can use our Pythagorean theorem. A squared plus b squared equals c squared. And right now you're just paying attention. But instead of a, and instead of b, and instead of c, what am I going to write for c, everyone? Very good, d, because that's the distance. What am I going to write for a? X sub 2 minus x sub 1. What am I going to write for b? Y sub 2 minus y sub 1. But I want to solve for d. What does that mean? That I need to take the what? Square root, and whatever I do to one side, I do to the other. Can I cancel this squared? Yes. Can I cancel these squares? Tell your neighbor why not, please. Because there's addition, so that means that stays how? Square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Students, distance formula. Distance formula. Students, copy that, please. Let's go. You don't need to copy all that, just copy the formula, because we're going to need the formula. And some of you are like, Mr. Q, that looks familiar. Yeah, remember when we did slope? Let's go. Everybody done copying that? Okay. Copy that really quick. 10 seconds. Let's apply it to a problem on your Cornell notes. Copy this one, please. Example 2. Compute the distance between the points 2, 3, 5, 7. And once again, I don't want this graphed, and I don't want to use the Pythagorean theorem. What are we going to use? The distance formula. All right. So here we go. Compute the distance between the points 2, 3, 5, 7. So I'm going to write D equals square root, parentheses, what's our distance? It's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. You're like, okay, how do we know which one's x sub 2 and x sub 1? Every time we read from left to right, this is our first one, yes? X sub 1, y sub 1. That means this one's our what? X sub 2, y sub 2. And now that we have those values, I'm going to use two different colors to make sure we see it. The formula stays the same. Parentheses, squared, plus, parentheses, squared. Look up also. Very important at this step. Look up. What is part of the formula? Minus and minus. Do that first, or else you're going to make mistakes when you substitute negatives from the values of the points. Okay? All right, Miguel, tell me what to write here. 5 minus 2. 5 minus 2. You got that? Yeah. All right. Next, what goes here? No. 7 and 3. 7 and 3. Yep. And all we have to do is simplify. D equals square root. What is 5 minus 2? 3 squared plus 7 minus 3, that's 4 squared. D equals, what is 3 squared? 9 plus 16. What is 9 plus 16? 25. What is square root of 25? 5 units. Let's go. Piece of cake? Yeah? Somebody was here on some GR with the distance formula? Yeah, 5, right? You have time for more? Yes, let's crank it up a notch. Yes. So here's the process. Write your distance formula, substitute values, but don't forget, look up please once more. I'm going to highlight it. Don't forget to write these negatives first before you start substituting, or else you're going to make mistakes. Just give me a heads up, okay? Let's do, no, too easy. Too easy. Bam. Copy that one. Example 2 mega cube. Compute the distance between the points. -5, 3, and -2, 5. Go. I'll give you a head start. Copy and go. Here goes the process. You write B equals, parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We label our points. This is our x sub 1, y sub 1. This is our x sub 2, y sub 2. D equals square root, parentheses squared with a negative inside, parentheses squared with a negative inside. All right, let's see. What is x sub 2? X sub 2 is -2. There it is. And what is x sub 1? X sub 1 is what? -5. All right. What is y sub 2? Y sub 2 is 5. And y sub 1 is 3. All right. D equals square root of, who noticed here negative and a negative here? That became what? Positive. So this is a 3 squared plus, what was this? 2 squared. Yes. D equals 9 plus 4. D equals square root of 13. You're like, wait a minute, Mr. Q. I know. Round to the nearest 10. Between what two numbers do we find that? 9 and 16. That means D is going to be approximately 3 point something. So let's see. What is 13 minus 9? 4. And what is 16 minus 9? 7. 4 divided by 7. Okay, I'll wait so I can finish. Zero. It's in there 5 times. That's 35. 5. It's in there 7. So that means this goes up to what? 3.6 units. And if you got that. Okay? Good one, guys. Enjoy your home play. There's only 10 problems today. Did I just wrap? Let's go. Log out, please. Retakes right now at lunch. If you're one of them, go get your food, come back. And your home play is only 10 problems. Good one, guys. See you guys tomorrow. Bye.